So you get your quiz on Monday, and then you got a quiz on the following Monday, the last day of class. So there's 2 more quizzes left. I guess now you're studying for Monday's quiz, the penultimate quiz. Just wanted to go over an example that's will help you out for the quiz. So we want to solve this differential equation with Laplace. And I've got the answer here already. I just asked the machine to solve it. But we can see the parts here, right? So this is y equals. I can see the parts here. Now, if I were to do this the chapter 4 way, I would have got the auxiliary equation, which would have been lambda squared minus 7 lambda plus 12. It would have factored into lambda minus 3 and lambda minus 4. So I would have got eigenvalues of 3 and 4. So the 2 little solutions, like the y1 and the y2, I see them here. There's some number e to the 3t, that must be like y1, and e to the 4t, that's y2. Those are the pieces that you would use the y1 and the y2 if you were going to do variation of parameters to get the particular solution. Now, the particular solution, of course, I wouldn't use variation of parameters on this example. I would use unknown coefficients because your guess would be a e to the t. So this must be the particular solution here, 1/2 e to the t. And these are the constants, and I get those from initial conditions. So solving this the chapter 4 way, especially when we already have the answer sitting there, is not too bad. Now let's do Laplace on it. So when we do Laplace, I'm using the chart, but a lot of this stuff we already have memorized from practice. The Laplace of y prime prime, s squared f, s squared f minus s y naught. So now y naught is 0. I'll put it in there. Of course, it makes the s disappear. Minus y prime naught. So that's the Laplace of y prime prime. Minus 7 times, I put the brackets in there so I don't mess up this minus sign. Now the Laplace of y prime is sf minus y naught, plus 12 times the Laplace of y, equals, now I'm Laplacing 3 e to the t. That's going to be 3 over s minus 1. So first step, take the Laplace of both sides. Now I'm going to solve for f. But in our step then, everything that has an f on it, let's see, there's f times here an s squared, a minus 7s, and a plus 12. Now I know I've got everything because this ends up being like the auxiliary equation, but instead of lambda, it's s. It's the algebra expressing the auxiliary equation. What doesn't have s? So this piece, s times 0, that goes to 0. The only piece, that's also 0. The only piece that doesn't have an f on it is this minus 1. And when I bring it over to the other side of the equal sign, it just becomes a plus 1. So our procedure, I think it's best to combine these together into one fraction before I divide out that auxiliary equation part. So instead of writing this as a 1, I'm going to write this as an s minus 1 over an s minus 1, because now it's common denominator together, and that's all going to be divided by the s minus 1. And what's on top? S minus 1 plus 3, that's s plus 2. So now I can divide out the auxiliary equation part. So f is equal to divided by, so I'm going to throw it on the bottom here, divided by, but I'm going to write it in its factored form. So that's going to be, what do we say, s minus 3 times s minus 4. Okay, so now I've solved for f, and I can see the pieces here. If I do partial fractions and break this up, there's going to be a some number over s minus 1. I guess I know what that number is going to be. It's going to be a half. some number over s minus 3. I know that number is going to be minus 5 over 2. Some number over s minus 4, that number is going to be a 2 when I break this up into partial fractions. So let's do that. Let's break this up into partial fractions. Now I'm just asking the machine to break it up. I never like the way it does that, but anyway. Because I would write that as a half over s minus 1. But we knew what the pieces were because we already had the answer here. So now I'm set to unLaplace. UnLaplace f, that's y, equals, okay, this is going to be 1/2. 1 over s minus 1 is that e to the t. I mean, we already know what we're getting. We already know the answer. Minus 5 over 2 e to the 3t plus 2 e to the 4t. And, I mean, I'm just retyping the answer that we already got the other way. But say I didn't even do this. Am I right? Well, when I put 0 in, I'm supposed to get 0 out of the solution. So you should at least check that. Oh, and I forgot the t here. So when I put 0 in, that's going to be 1/2 minus 2.5. That's, okay, minus 2 plus 2 is equal to 0. So yes, it does go through that. And you could, I mean, it's easy enough to differentiate it, right? E to the t is e to the t. Here the 3 comes down, so that's 15 over 2. Here the 4 comes down, so that's 8. So 1/2 minus 15 over 2. 1/2 minus 15 over 2 plus 8 is 1. So it does go through this piece. And I can see the pieces, the e to the t, the e to the 3t, and the e to the 4t that I expect to get. So I'm not saying that when you solve something with Laplace that you should solve it the other way first, but I am thinking that you should at least put thought into the eigenvalues and what the particular solution should look like. You should just be able to look at this and know not exactly what the answer is, but what the answer's form should be from the eigenvalues.